Well, you've finally done it. You are at the first day of the CO2 Dragster project, or maybe this is a second time through for you, but anyway, we're going to get you set up with an overview and a little getting started video on the famous CO2 Dragster project. So, first of all, we're going to start with a little talk on basically the background, or actually the overview of the project. But what I always like to do, of course, give any references, and this link right here, which you're probably not going to be able to type in very easily, but this is where a lot of my references came from. I'm going to use some slides from the NYU website, nyu.edu. So we give credit to those guys for creating a really nice slideshow that I'm going to use part of. So, how do you make a great car? Well, it's a pretty simple process. There's 6 steps in essence. The first step is to understand the engineering principles. That's number 1, which we'll get into in this presentation. The second thing you need to do is know the rules of the race, which we know in this lab as the design envelope. The third thing is research and decide on your design, thumbnails, small scale, and full scale template. And then number 4 is cut and shape the car, which is a fairly lengthy process, but especially the shaping part. But once you cut and shape the car, you need to, of course, smooth it up, and then we'll apply the finish to it. Usually that comes in the form of primer and paint. And then finally we'll assemble the hardware, the wheels and axles, the eye hooks on the bottom, and we'll give it a test in the wind tunnel to see how it's going to compare to other cars. So what I'm going to do is talk about the understanding the engineering principles. So we're going to go all the way back to step number 1. And I'm going to flip on over to a little presentation here on engineering principles, and this is again from the nyu.edu site. So engineering principles, basically what you need to know about designing a CO2 powered race car is 4 things of engineering, or 4 things relating to engineering, and that's Newton's laws of motion, mass, drag, and friction. And actually you're going to see in your Blackboard page, let me just take a time out from that for a second. You go over to your CO2 Dragster page in Blackboard, and you see, of course, there's a study guide, which you're going to want to right mouse click and save target as. I'm going to download it to my mod tech folder I've created for this sample. Click save and open. This is a study guide that you're going to want to use to prepare for your module test and then finally your final exam. So you see there's a bunch of questions there relating to this module. Close that out so that you can see that. Okay, so understanding the planning process. So what you're going to need to do is get into this Science of Speed web quest, and all you need to do is save this, save target as, save it up, and say yes, click open. And here is the Science of Speed web quest. Now, how to fill it out, I'm going to go rather quickly, but you just double click, put your name here, your hour, I'm just going to say hour 1, and you click on the close button here on this little tab, and there you go. Okay, so your Science of Speed web quest. So Science of Speed is a really cool website that's going to take you through a bunch of different, or present to you a lot of different information on how to deal with or how to create a CO2 dragster. So these questions can just be answered by typing your answer right in here in these little boxes. You go to the Science of Speed website, learning what is CO2 racing, and if I go back over to my Blackboard page, you can click on the Science of Speed site here, and it'll take you in there. So again, learning what is CO2 racing, and then you can go ahead. You can go ahead into the different categories. So what is CO2 racing, science, the second page, science friction, and then the engineering section. And then number 14, make sure you answer that. Now there's some instructions here, I might as well show you. It says when finished, go to file, print, and change the zoom setting to 2 pages. Okay, I'm going to show you something. Let's say that we made a entry in here, and I'm just going to go ahead and put a bunch of garbage in here. Let's say we made an entry like that. Now I'm going to hold down Control and scroll back. See what happened? I have a blank page in there because I have too much here. All you need to do to correct that is put your cursor, just click there, and hit the delete button, and you can see it pops it back to 2 pages. Okay, so again, Control and scroll. back and forth, and you can zoom in and out. So basically what you're going to do when you're all done with this, you go to File, Print, and according to the directions down here, you change your pages per sheet to 2 pages. And then once you do that, I'm just going to cancel this out so I don't print one. It's going to print both of these sheets side by side on the same page. It's actually pretty cool, good way to save paper. But again, make sure that you do not have this blank page in there. Just go ahead and click on the blank page, hit the delete button. Maybe once or twice it'll get you back where you need to go. Okay, so we're going to go back over, and I'm going to Alt-Tab, as I've shown you before on this, over to the Science of Speed site. We're going to Alt-Tab over to our presentation on engineering principles. Okay, so after this little sidewalk for us, we're going to come back to engineering principles. Okay, so how does this work? Well, engineering principles starts with Newton's second law of motion. What Newton's second law of motion says is that the greater the force, the greater the action. Okay, so if you push something really hard, obviously you're going to have it react harder. So it's pretty simple. Acceleration is dependent upon, or depends upon, the mass and force of the car. And there's a little formula here. Force is equal to mass times acceleration. All right, and this isn't a physics class, but that kind of gives you the background behind it. So in essence, for a fast car, you're going to need a big force, and the force we use is a CO2 cartridge, so you don't have to worry about how much force. It's going to be the same force for every car. But you certainly need a light car. So you need to focus on making as light a car as possible. Okay, let's talk about mass. And as it says right up here, more mass means you need more mass to accelerate, or excuse me, more force to accelerate. So the more mass something has, the more force you need to get it to move. So there's a balancing act here. There's advantages. Cars with less mass go much, much faster. It's a fact. The disadvantage, however, is cars with less mass are also less stable and less durable, so they could break easy. So you don't want to make them too thin, plus we have rules against making them too thin, so you need to watch out for that. All right. Does it take more or less force to push 40 grams than it does to push 130 grams? Well, obviously, it takes less force. So, acceleration. Acceleration is produced by the CO2 gas cylinder. So like I said, all of this is going to be the same for all the cars. Okay, so that's pretty much all we need from this one. Now, forces of resistance. We call this drag in this case. Drag is the resistance, or excuse me, from air resistance. So it's basically the resistance of the air. It's air friction. So you can see they have a nice little diagram here. If we're going in the X direction here to the left, okay, FW is the indication of drag. So drag, of course, is coming at the car as the car moves forward. You've got the wheels rotating this way, backwards toward the back of the car, obviously. And so any resistance we have is in the form of drag. So if you took a piece of wood and just slapped wheels on it, and you shot it down the track at 60 miles an hour, and the air rushing over the body and the wheels, obviously we'll try to slow it down. So scientifically we call it drag, which is the resistance of wind moving over an object. All right, so to minimize drag, we need to make sure that we, first of all, make the car aerodynamically shaped. And the advantage is, of course, aerodynamically shaped cars have less drag, so they go faster. The disadvantage, aerodynamically clean cars, or good cars, are difficult to build because you have to round the edges off, you want to shave material off, you want to make it as light as possible, so you have more labor work to do. Friction. Friction is basically a product of gravity. So on a CO2 car, we find friction in basically three places: between the wheels and the ground, which we really can't help because we're rolling along the floor; between the axles and the car body, which we can help in the form of, as you'll see when you put your hardware on, your washers, little gold washers; and then of course between the eye hook and the fishing line track. So how to minimize friction? First of all, make sure the axle and the tires are free to rotate. We have a few tricks that we'll show you on how to make sure that happens when you test the car. The second thing is make sure the wheels are not rubbing on the car body, and again, we help prevent that with not only making sure they're put on correctly, but also making sure that we have the little gold washers to help minimize that friction. And then finally, of course, be sure to install your eye hooks properly. If you have eye hooks that are poorly aligned, they're going to slow down the car. Okay, so what is the best design for a CO2 racing car? Now, they talk in this little presentation about the TSA requirements right here. We have our own requirements, which are based off of the TSA, which is Technology Student Association. It's a national group that agrees upon requirements for this project. But in essence, the best design is the one that wins. There is no one design that is the best. Absolutely not. The one design is the design in your class, who you're competing against, all the other cars in your class. That best design is the one that wins. Okay, so I've seen a million times where I have short cars beat long cars beat short cars. I've had aerodynamically good cars that are heavy that beat lighter cars. So it's really all over the place. But in essence, the two best indicators are a good car, they're clean of aerodynamics, and high craftsmanship. So in other words, a really good design that's built poorly will lose to so-so designs built well. Okay, so that's essentially what we need to get from this. Okay, so we're going to hold off right there. So again, just to recap, you need to understand the engineering principles, know the rules, research and design, cut the shape of the car, and apply your finish. And if you know how to do all that, or once you get through all that, that's your 20 days. So again, going back to Blackboard, your first thing you need to take care of at this point would be to go to your CO2 Dragster page, download not only your study guide, but your Science of Speed web quest, finish that, print it up according to the directions, and then the next demo will take you through how to research ideas for your dragster.